Now we are given this question. We are required to prove that cos theta minus cos theta sine squared theta is equal to cos exponent of 3 theta. So we check which side amongst the two looks complicated. In my view, I think left hand side it's a bit complicated, so I'm going to deal with the left hand side. So we'll simply say left hand side is equal to cos theta minus cos theta sine squared theta. Now let's try to simplify the left hand side. This one can be written as cos theta minus cos theta, but bear in mind we are having sine squared theta. We know that sine squared theta, from the square identity we have sine squared theta plus cos squared theta, it's equal to 1. That means that sine squared theta is equal to, we can transpose this cos squared theta to the other side, which will give us 1 minus cos squared theta. And then instead of writing sine squared theta, we can write 1 minus cos squared theta. So let's quickly erase this part here so that we have enough space. Now we are going to replace, we are going to have 1 minus cos squared theta. We enclose the bracket, then we go on further to simplify. This is cos theta minus, we'll have cos theta multiplied by 1, which will give us negative cos theta, and then a negative cos theta multiplied by negative cos squared theta, which will give us positive cos exponent of 3 theta. Ultimately, these two are like terms, they will eliminate each other. We remain with cos exponent of 3 theta. Therefore, one can conclude to say that left hand side is equal to the right hand side. That's it. Now let's look at this question. We are told to prove that 1 divided by cos squared x minus tan squared x is equal to 1. You need to bear in mind, before we check a proper way to solve it, think that the complicated side in our case is the left hand side. We just say left hand side is equal to 1 divided by cos squared x minus tan squared x. But what is tan squared x? We know that tan x is same as sine x divided by cos x. So we are going to change tan squared x to be sine squared x divided by cos squared x. So we can write this thing as 1 divided by cos x minus, sorry, this is squared, minus sine squared x divided by cos squared x. This is our left hand side. Now from this we know that if we have a divided by b minus c divided by d, we use the denominator method, or the numerator method. Will have a multiplied by d minus c multiplied by b, all divided by b multiplied by d. So this is what I'm referring to. So now in our case we'll have 1 multiplied by cos squared x, which gives us cos squared x, minus sine squared x multiplied by cos squared x. Everything should be divided by cos squared x multiplied by cos squared x. From this, if you check, in the numerator we have got a common factor which is cos squared x. So we take out cos squared x. After taking out cos squared x, you remain with 1 minus sine squared x, all divided by cos squared x multiplied by cos squared x. So these two will divide each other. We remain with 1 minus sine squared x divided by cos squared x. But from trig identities, we know that sine squared x plus cos squared x from the square identity is equal to 1. So we can write cos squared x as 1 minus sine squared x. This is the same as cos squared x. So instead of writing 1 minus sine squared x, we can safely say this is cos squared x divided by cos squared x, which simplifies to 1, and therefore left hand side is equal to the right hand side. That's it. Now let's look at this question here. We are required to prove that the left hand side is equal to the right hand side. So in my view, still the complicated side in our midst is the left hand side. So we'll copy the left hand side as it is. Left hand side is equal to 1 divided by 1 plus sine squared x plus 1 divided by 1 minus sine squared x is equivalent to, sorry, we don't say it's equivalent to, thereafter. Now let's quickly simplify it. If you have a divided by b minus c divided by d, its simplification is a multiplied by d minus c multiplied by d, this is multiplied by b, all divided by b multiplied by d. So we are going to apply what is normally referred to as the butterfly method. We'll have 1 multiplied by 1 minus sine x. So sorry, this is just sine x, I made a mistake. So we are going to have 1 minus sine x plus 1 plus sine x, all divided by, in the denominator we just have 1 plus sine x and 1 minus sine x. So in dealing with this, we are just going to have 1 plus sine x, 1 minus sine x. So in the numerator we can see that we have like terms. Negative sine x plus sine x will result to 0, then we'll remain with 1 plus 1, all divided by 1 multiplied by 1 will just give us 1, then minus sine x plus sine x, then the multiplication of the last terms, it will just give us negative sine squared x. Then we remain with 2 in the numerator, and then in the denominator we just have 1 minus sine squared x. But we know that from the square identity, sine squared x is equal to 1 minus cos squared x. And in the same breath, cos squared x is same as 1 minus sine squared x. So this thing can be written as 2 divided by, instead of writing 1 minus sine squared x, we can just write cos squared x. It is evident that left hand side is equal to the right hand side. Now let's proceed. Let's look onto this one. In solving this one, it is too evident that the left hand side, it's a bit complicated. We have sine x plus cos x squared plus into sine x minus cos x all squared. All we just have to do is just to show that the left hand side is 2. So in showing that the left hand side is 2, this is what you do. You are going to simplify whatever that we have here. When you simplify it, we are going to have sine squared x, square of the first term, then 2 multiplied by sine x multiplied by cos x, which will give us plus 2 sine x cos x. Thereafter plus cos squared x. We are done with the first bracket. Let's change the color to red. Then we'll have plus here. We'll have plus, then red will be dealt with using this one. We can simplify this one using, we'll have sine squared x. And then if you check in the middle, we have a negative, so we are going to have a minus 2 sine x cos x, then the square of the last term, which will be plus cos squared x. Ultimately, we try to group the like terms, or that which we see that they can give us something that we are used to. We can write sine squared x plus cos squared x near each other. Thereafter plus 2 sine x cos x. Then plus this side, let me change it to a different color. I can also come this side and then write sine squared x plus cos squared x minus 2 sine x cos x. You should bear in mind that this which we see here, it's a square identity. This which that we see here, it's an identity, square identity, double angle of sine. So this one will result to 1 plus sine 2x plus 1 minus sine 2x. Remember, this is a double angle for sine. This is double angle for sine. So now these two are like terms. They will eliminate each other. We remain with 1 plus 1. Thereafter our answer will just be 2. Therefore left hand side is equal to the right hand side. That's it.